Every formula you were ever made to memorize in a physics class, every law, every symbol on every dreaded revision sheet you crammed an index before an exam, the whole intimidating pile of it comes from a handful of ideas, small enough to fit on a napkin. That's the thing nobody tells you when you're 16 and terrified. Physicists don't win by remembering more than everyone else. They win by needing to remember almost nothing.
And here's the part that should keep you up tonight. The strange thing isn't that a few small ideas turn out to be that powerful. We could just about live with clever. The strange thing is that the universe agreed to go along with it. That reality, actual planets, actual light, answers to a few marks somebody made on a page.
So that's the door I want to walk through with you. How does that much world come pouring out of that little? And the one that gives me an actual shiver. Why on earth should nature care what we scribble? Why does it listen to mathematics at all? Don't let me off easy on either of those.
I won't. Those two questions are the entire reason this course exists. And the second one I can't answer at all, which I'll prove to you before we're done. But let me start with the good news, the kind that undoes years of quiet dread. Most people meet physics as a wall of formulas arriving faster than you can file them, each one a separate thing to fear and forget. That wall is real, but it is not the physics. It's the exhaust.
The exhaust? That's a strong word. You're not saying the formulas are useless, are you? People do real things with them.
They're not useless at all. You steer a spacecraft with them, you hold up a bridge with them. I'm only saying they're downstream. The exhaust of an engine still moves the car, it's just not where the power is made. Spend your whole life staring at the tailpipe and you'll never understand the engine. Most of us were handed the fumes and told they were the machine.
Okay, but before you say one more reassuring thing, I need to name the fear out loud, because I still carry it. Please tell me this course is not going to end with a table of formulas I'm supposed to tape to my wall and chant before an exam.
It is the opposite of that. If anything, the working physicist's wall is embarrassingly bare. When someone who does this for a living sits down in front of a problem they've never seen, they are not flipping through 1,000 memorized laws, hunting for the right one. They're carrying a few ideas, you could count them on one hand, and everything else they build on the spot as they need it.
See, that already sounds too good, and my suspicion is up. Where did all the formulas go? They exist. I've held the textbooks. They're heavy. Something has to be storing all of that.
The textbook stores them, the way a phone book stores every number in a city. But nobody memorizes the phone book. Those 1,000 formulas are consequences. They're what you get after you take one of the few ideas and follow it downhill into one particular situation. This shape, that force, this constraint. The formula on the sheet is the finished piece of furniture. What we're after is the tree it was cut from. And here's the thing about a tree. It keeps making new branches. Hand someone the few ideas and a problem no one's ever posed, and they'll grow you a formula that was never in any textbook. One nobody had needed until that afternoon. You cannot do that with a shoebox. Receipts don't grow.
Can I test that on something specific? In school, there was this one equation for a ball thrown through the air. How high it climbs, when it lands, the whole arc. I memorized it cold, and I still couldn't have told you where it came from. Are you saying that one's a receipt too?
A receipt, top to bottom. That arc formula isn't a law of nature. It's what falls out when you take one deeper idea about how things move and pour it into the exact shape of a ball near the ground with gravity tugging down. Change the situation and the formula changes with it. The idea underneath doesn't budge an inch. You memorized the shadow and were never once shown the thing casting it.
So the sheet of equations isn't the subject at all. It's more like the receipts, proof that somebody already did the work once.
I love that, receipts. And most physics teaching, through nobody's fault really, hands you a shoebox stuffed with receipts, and never once shows you the shopping. You come away thinking the subject is the receipts, that being good at physics means owning more of them and pulling them out faster. It's backwards.
This is going to sound petty, but I'm properly annoyed on behalf of my younger self. If the real thing is a handful of ideas, why did anyone ever make us memorize the shoebox?
Partly because the receipts are easy to mark. You can grade an exam full of formulas with a red pen and a stopwatch. It is far harder to grade whether someone truly sees why the world had to come out the way it did. So the gradable surface got mistaken for the thing underneath it, and a whole generation learned to fear the surface. This course is one long walk back to what's under it.
There's real relief in that, and also a suspicion I can't shake. If it's really so few ideas, then why does everyone act like physics is the hardest thing in the world?
Because finding the few is savagely hard, even though carrying them afterward is light. It can take a century and a mountain of clever wrong guesses to find the one idea that folds 1,000 facts into a single sentence. But once it's been found, you and I get to just pick it up. We inherit the compression. All the difficulty was upstream in the discovery. What's left for us is the good part, walking around inside the finished idea.
So learning physics isn't really filling a bucket then? It's more like getting a new pair of glasses.
That's the truest way I've heard it put. You don't end up with more facts crammed in. You end up seeing the same world differently, so that things that looked like 100 separate rules suddenly look like one rule seen from 100 angles. Nothing gets added to the world. Something changes in you. And once the glasses are on, you can't take them off. You'll never look at a falling apple or the moon the same way again.
You keep saying how physics is actually written, and it's stuck to me, but I want to feel it, not nod at it. Give me a taste. Show me one real case where a few ideas swallow an enormous amount of the world.
The cleanest case is also the oldest, and it's still the best one we've got. So picture the sheer amount of sky, every falling thing you've ever watched, a dropped cup, rain sliding down a window, a coin skidding off the edge of a table, and then completely separately, the heavens, the moon going round and round, the planets on their slow, enormous loops, comets that vanish for a lifetime and come back on schedule.
And for most of history, those were two different worlds, weren't they? Down here, ordinary falling. Up there, something practically holy.
Two different worlds with two different sets of rules, and nobody imagining a bridge between them. Earthly stuff falls, heavenly stuff wheels. That's simply how it is. And then one man, Newton, asks a question that sounds almost like a child's. What if the thing that tugs the apple down out of the tree is the very same thing that keeps the moon from sailing off into the dark? Not similar to it. The same one rule, running both jobs at once.
Okay, but hold on. The apple hits the ground in a second, and the moon has been up there for billions of years and never lands. How can those possibly be the same thing happening?
Because the moon is falling. That's the sentence that stops people cold. The moon is falling toward us the entire time. It's just also moving sideways so fast that the ground curves away beneath it, exactly as quickly as it drops. It is forever falling and forever missing. The same fall as the apple. The only real difference is the sideways speed.
So if you could somehow speed the apple up, really fling it sideways, faster and faster, at some point it just never lands?
At some point it falls all the way around and comes back to tap you on the shoulder. That was Newton's own picture. Imagine a cannon on a mountain so tall it pokes above the air, firing harder and harder, until the cannonball is falling exactly as fast as the earth curves away under it. And now it isn't a cannonball anymore. It's a moon. A thrown stone and a moon aren't two things. They're one thing at two speeds. Once you see that, you can feel the compression happening inside your own head.
That does something to me. The moon is falling. I've looked up at it my whole life and never once seen it as a thing that's in the middle of falling.
And notice what Newton actually did there, because it's the move this whole course is about. He did not fly up and catalogue the heavens, memorizing where each light sits. He found a few rules, a small handful, and out of them tumbled the apple, the moon, the ocean tides, the planets, even the return date of a comet no living person had ever watched come back. An ocean of separate facts, wrung out of a thimbleful of assumption.
Wait, the tides too? The sea heaving in and out twice a day falls out of the same handful of rules as the apple.
The same handful. The moon tugging on the oceans, the water heaping toward it and away from it as the earth turns underneath. Same rule, wearing yet another coat. That's the thing I want you to feel. It isn't that Newton kept one rule for apples and a spare one for tides and a third for comets. He had the few, and the many came pouring out. The apple, the sea, the comet on its long loop. One idea, 4 disguises.
The comet one gets me most, actually. A comet swings out, disappears for longer than a human lifetime, and the handful lets you write down the year it comes back, when nobody alive today will be around to be proven right.
That's the sheer nerve of it. You compress the whole sky into a few rules, turn the crank, and out drops a date so far off that the person doing the arithmetic will be long gone before the sky confirms it. And the sky confirms it. That's not Newton being clever about the comet in particular. It's the comet and the tides and the apple all being the same short idea, so that pinning one of them down quietly pins down the rest.
And that ringing out is the thing you keep circling. It has a name?
It has a name, and it's the real subject tonight. Compression. Taking something enormous and folding it down small enough to carry in one hand.
Compression. Like squeezing the whole sky into something you can hold.
The whole messy sky, folded into something that fits in a palm. And I want to be careful not to carve Newton into a marble saint here. He was a strange, prickly, difficult man, and he got plenty of things flat wrong. What matters isn't the man, it's the shape of what he pulled off. He replaced a library with a sentence, and the sentence did more than the library ever could, because a library only holds what someone already wrote down, while the sentence answers questions no one had thought to ask yet. That shape, much from little, is what physicists have been chasing ever since, because once you've watched it work, going back to memorizing feels almost embarrassing.
So the great dirty secret of physics is that physicists are lazy.
Profoundly lazy. Gloriously, world-historically lazy. But it's a very particular flavor of laziness, the kind that flatly refuses to remember 1,000 things when 3 will do, and then goes to absurd, decade-long lengths to find the 3. A physicist would frankly rather stare at a blank wall for a month chasing one idea than memorize 100 facts over a weekend. It looks like sloth from the outside, and it is the exact opposite from the inside. A willingness to be baffled for a very long time, to sit in the not knowing for months, rather than reach for the comfort of one more fact to file away. Lazy about facts, bottomlessly patient for ideas. Those two always travel together in the people who are any good at this.
And nature just goes along with that? It keeps arranging itself so the 3 actually exist to be found.
Over and over it does. And that's the quiet miracle sitting underneath the laziness. There is no law anywhere that says a universe has to be compressible. It could have been an endless list of unrelated facts, each one its own separate rule, nothing folding into anything else. It just isn't. The 3 keep being there, waiting for us. It's the same bet every time, and it keeps coming good. You dig under a mess of facts, expecting more mess, and instead you hit a flaw, and the flaw is simple. Nobody promised us a flaw. We just keep finding one. Which brings us to the word in the title of this series, because you've been circling it too.
I have, and I want it pinned down. A first principle. It's the name of the entire course. What actually is one? Because right now, if I'm being blunt, it just sounds like a fancy way of saying a really good idea.
It's far more specific than that, and the difference is the hinge the whole course turns on. A first principle is not a fact you look up. It's not a formula you're handed and told to trust. It's a demand, a condition you place on the world and insist it must obey. You say, whatever else turns out to be true, this must always hold. And then, here's the part that feels like sleight of hand. Once you've committed to that demand, the specific laws stop being optional. They're forced. They have to come out one particular way, or your demand would be broken.
Say that slower, because I think the floor just shifted under me. You don't start from the laws, you start from a demand, and the laws are whatever's left standing afterward.
The laws are whatever survives the demand. Picture it this way. Instead of collecting 1,000 facts about how things fall, you make a single insistence about the world. One sentence about what the universe is simply not allowed to do. Then you ask, given that this can never be violated, which motions are even permitted? And the astonishing part is how little gets through. Out of everything imaginable, only a razor-thin sliver of behavior is consistent with your one demand. And that sliver is the physics we actually see. Think of it as a filter. You pour in every motion the world could conceivably perform. The sensible ones and the absurd ones, all of it. And your single demand catches nearly all of them and lets only a trickle through. What comes out the bottom, you didn't design. You only chose the filter. The trickle chose itself.
Give me an everyday version of that, because a demand that forces the laws still floats a little. When does insisting on one thing force everything else?
Think of a rule as plain as, the books must always balance. A good accountant doesn't memorize what every entry ought to be. They insist on that one thing. Every penny out matches a penny accounted for, and suddenly whole columns of numbers are forced. Move one figure, and the rest have to shift to keep the books balanced. Nature's demands work like that, only the books are things like motion and energy, and the balancing is far stricter than any accountant ever dreamed.
That's a completely different feeling from memorizing. Memorizing is, here are the answers, learn them by Friday. This is more like being handed the one rule of a game and discovering the legal moves derive themselves.
That's the flip, and you landed it faster than I did. But I have to slip one caution in right here, because it's load-bearing and almost everyone skips past it. These demands, these first principles, we do not prove them. There is no argument, starting from nothing, that forces us to adopt them. We choose them.
Wait, we choose them? So a first principle could just be wrong? We're picking the ground we stand on?
We are picking the ground we stand on. That word, first, doesn't mean proven before all the others. It means the place we start from. A floor we choose to stand on, not a floor we dug down to and struck as bedrock. We adopt a principle because, when we bet on it, the universe keeps paying out. We demand that something be true. We follow the consequences all the way down. We check them against the world, and the world keeps agreeing. So we trust the demand, not because we wrung it out of the void, but because it has never once let us down.
But if we just choose our starting points, what stops it from being arbitrary? Couldn't I insist on any old thing and call it my first principle?
You could insist on anything, for about an afternoon. The world is a brutal referee. Nearly every demand you could dream up dies the instant you follow it out and check, because it predicts a universe that plainly isn't this one. The ones that survive are staggeringly rare, a tiny few you can push as hard as you like and never once catch out. So the choosing isn't free. We propose, the universe disposes without mercy and hands back a very short list. It's the strictest game there is, and losing is instant. That's what keeps first principles trustworthy. not our cleverness, but that the world will fail us in a heartbeat the moment we're wrong, and never once soften the blow to spare our feelings.
So it's a bet that keeps winning, not a theorem carved into the bedrock of reality.
A bet that keeps winning. And a careful physicist holds it exactly that loosely, ready, in principle, to give it up the day the universe stops paying. That humility comes back hard at the very end of this course, so keep it in your pocket. But don't let it hide the power, because look at what a single, well-chosen demand actually buys you.
Go on, what does one demand buy?
An ocean for a thimble. You make one insistence, and out of it fall pages and pages of specific, testable, unarguable law. Motions you can predict, numbers you can check, behaviors nobody had catalogued in advance that turn out to be waiting exactly where the demand said they'd be. You put in a sentence, and you get back a library. And you don't get it back all at once either. That's the other lovely thing. You keep coming back to the same one demand for decades, asking it new questions, and it keeps answering, as if there were far more folded inside it than you put there. A good first principle is a well you don't reach the bottom of.
I keep waiting for the catch. A sentence in, a library out. That ratio sounds too generous to be real.
The ratio is almost indecent, and it's the whole reason anyone becomes a physicist. There is no other trade like it. In most of life, you get out roughly what you put in. Here you put in one carefully chosen sentence, and the universe hands you back centuries of consequences you never even asked for. It ought to feel like cheating. The only reason it doesn't is that finding the one right sentence is so punishing that we've earned every book that falls out of it.
And is that how the famous modern stuff was built too? Or is Newton a lucky one-off, a nice old story that doesn't repeat?
Not a one-off at all. It only got more extreme. The most celebrated physics of the last century, Einstein's, was this exact move done without mercy. He didn't begin by collecting facts about light and clocks. He began by planting his feet on a demand, an insistence about what the laws of nature must look like to everyone, everywhere. And then he refused, flatly refused, to let go of it, no matter how strange the consequences turned out to be. And they turned out very strange. But they were forced. That's principle first physics, and it's the tradition this whole course lives inside.
So the pattern holds across the centuries. Plant your feet on a demand, follow it without flinching, and let the world be as weird as it needs to be.
Plant your feet and don't flinch. And here's the crucial thing about that following out before we go anywhere near the mystery. The following out is ordinary, beautifully, reassuringly ordinary. Once you've accepted the demand, getting the laws out of it is patient, checkable reasoning. Hard work, sometimes years of it, but nothing spooky. Anyone who follows the same steps arrives at the same place.
You're putting a lot of weight on that word, ordinary. Why? It almost sounds like you're warning me off something.
I am, a little, because there is something spooky in this story, and I don't want you to misplace it. It is not in the reasoning. The reasoning is craft, the same kind of craft a careful accountant or a careful carpenter would recognize. Keep that firmly on one side of the room. The mystery lives on the other side entirely, and it's time I walked you over to it.
Then walk me over. You've been dangling it since the first minute. Why does nature listen? I want the actual thing now, not the trailer for it.
All right. Let me lower us into it gently, because it deserves a little quiet. We've been saying breezily, choose a demand, reason carefully, outcomes law. Fine, but stop and look at what that sentence is really claiming. It's claiming that a person can sit at a desk with a pencil, pushing little symbols around according to the plain rules of arithmetic, and that when they finally look up, the sky will have gone and done what the symbols said it would.
When you lay it out that flatly, it sounds close to insane. Marks on a page. And a comet. A real mountain of ice, out where no human being has ever been. obeys them.
Tells you where it will be in 100 years. Not roughly, to the day. Somebody does a stretch of arithmetic in a quiet room, and a thing the size of a mountain, out in the cold and the dark, arrives on the date the arithmetic named. We've heard physics works so many times that the sentence has gone numb on us. Let it wake back up for a second. Why should that be possible at all?
Yeah, why should it? The universe didn't sign a contract with us. There's no reason a lump of rock should care about our notation.
None that anyone knows. And that, more than anything else, is what I want you to carry out of tonight. The universe did not have to be writable. It could have been lawful, but not expressible. Orderly in some way that no symbols could ever catch hold of. Or it could have been lawless from top to bottom. There is no rule of logic anywhere that says a world must be describable by mathematics. And yet, in every corner we have ever looked into, it is. The marks work, and we do not know why. Think how easily it could have gone the other way. A world where every new thing you studied needed a brand new rule, unrelated to the last, so that no amount of cleverness ever let you get ahead of it. You'd just be forever cataloguing, never predicting. That world is allowed. It's even, in a way, the more likely sounding one. We simply don't live in it, and nobody can tell you why we got the writable one instead.
And it's not only about predicting things we already knew about, is it? I've got a vague memory that sometimes the math got out ahead of us.
That's the part that turns the wonder up past reason. Sometimes the symbols don't merely agree with what we've already seen. They insist on something nobody has ever seen, a thing there was no reason on earth to suspect, and they say, "Go and look, it must be there." And we go and look, and it's there. The page knew about a piece of the world before any human being did. Predicting tomorrow's sunrise is one thing. Being told by your own arithmetic to expect an entirely new kind of thing, and then finding it exactly as described, that's when the marks work, stops sounding like a convenience and starts sounding like a message we can't read the return address on.
I need to be sure you mean that the way it sounds. Not, we don't know yet, ask again in 50 years. You mean there is genuinely no answer sitting in a drawer somewhere, waiting.
I mean it flat. This is not a gap we quietly plug in a later episode once you've had enough background. It isn't homework I'm deferring. It's a real open wonder, one of the deepest we have, and it sits directly under the foundation of everything else we're going to build. If I told you we'd solved it, that would be the single place in this whole course where I'd be lying to you. So I won't. We are going to build the entire cathedral, on a floor we cannot explain.
And does that sit all right with physicists? Building everything on a floor you can't explain, doesn't that keep people up at night?
It should, more than it does. And I'll admit the working days can slide by without a single thought for it, because you're busy turning cranks. But every so often you catch it again, usually late, usually tired, and it stops you dead. That a squiggle you wrote an hour ago just told you something true about a star you'll never visit. The people who stay amazed by that are the ones I trust the most. The mystery isn't a problem to be managed away. It's the thing worth staying awake for.
Okay, that's a lot to just sit with. But I have to prod it because I've definitely heard people wave it away. Somebody always says, "Oh, that one's easy. The universe just is mathematics. It's literally made of the stuff. Of course it obeys the math." Doesn't that dissolve the whole mystery in a line?
It's a real position, and serious people hold it. But listen to what kind of thing it is. The universe is made of mathematics is not a fact anyone has ever demonstrated. It's a stance, a philosophical bet about what reality fundamentally is. And there are equally serious people who think it's exactly backwards, that mathematics is only the net we happen to fish the world with. Both camps are, in the end, guessing. So no, I won't let us pocket it as an answer.
So it's not that the universe is math people are being silly, it's that they've swapped a mystery for a slogan and hoped nobody would notice the switch.
That's it. Naming the wonder and then quietly sliding a slogan into its place would be the same cheat as pretending we'd solved it outright. One is a loud dodge, the other's a quiet one, but they're the same move. So the rule of this house is simple, and I'll hold myself to it all season. We are allowed to feel the full weight of the wonder. We are not allowed to fake the answer.
I like that as a house rule. Feel everything, fake nothing.
And I'd push it one step further. The wonder isn't a flaw in the story that we have to apologize for. It's the best thing in it. Everything we build from here sits on top of this one staggering, unexplained fact that reality answers to marks on a page. We just don't get to pretend we know why it picked up the phone when we called.
The sky checked our arithmetic and agreed. I'm going to be turning that one over for weeks.
Turn it over as long as you like. This is the one place where "I don't know" is the most grown-up sentence physics can say. But there's a second gift hidden inside the mystery, and it's the reason there's a whole course here instead of just one stunned episode. The fact that nature is writable at all means there is something to write, and what turns out to be worth writing is shockingly short. All of it, so far, hangs off a very small number of ideas, arranged in a particular order, each one running deeper than the last. If you tried to write down every fact about the world, you'd never stop. That list is bottomless. But you don't have to. You write the few, and the many are implied, the way a handful of grammar rules implies every sentence you will ever speak. That's what a physics really is. The grammar of a world, not its dictionary.
Is there something special about the count, though? Or is that just where you happen to draw the lines?
No cosmic significance to the number. Don't let anyone sell you a magic count. It's simply where the world's joints happen to fall, the natural places to cut. You could carve it a little differently and land on 5 or 3. What matters isn't the tally, it's that the number is small, that this whole roaring subject folds down to something you can list on the fingers of one hand and still have a thumb to spare. Small enough to carry, that's the only property that counts.
And those few, in their order, that's the map you've been promising me all night. The actual shape of the journey. Lay it out. Where do we go and in what order?
Here's the whole climb then. A few ideas in order, and I'm going to show you the shape of each one without handing you a single one of them tonight. Tonight is the map. The territory starts next time. Deal?
Deal, map only. I'll sit on my hands.
The first idea, where we go the moment this episode ends, is the deepest habit nature has, and it's almost comic how lazy it turns out to be. Of all the countless paths a thing could take to get from where it is to where it's going, it takes the most frugal one, the most economical, as though the universe were quietly adding up a cost for every possible route and always, without fail, choosing the cheapest one on the list.
The most frugal path. So even that, even the universe being cheap, counts as one of these demands.
It's the demand in its purest form. One insistence, take the thriftiest route, and out of it falls motion itself. The thrown ball, the swinging pendulum, the planet in its orbit, and eventually, astonishingly, light. That's how deep it runs. And it doesn't feel like a rule when you meet it. It feels almost like a personality. As if the world has a temperament, and the temperament is thrift, and once you know that about it, you can predict what it'll do the way you can predict a frugal friend at a restaurant. We'll spend the next few episodes doing nothing but unfolding that single idea. It has a name we'll come to love, the principle of least action, and it was worked into its full power generations after Newton by a French reformulator of mechanics we'll meet properly in his own episode.
Cheapest by what measure, though? Cheapest in distance? In time? You can't just say cheap and leave it hanging.
You've put your finger right on the next episode's whole job, because cheap in what, precisely, is the question, and the answer is subtler and more beautiful than distance or time. I'm going to refuse to tell you tonight, on purpose, because the instant I name the thing nature is being thrifty with, we've walked off the map and onto the trail. For now, hold only the shape. Of every route on offer, the world takes the bargain. What the bargain is counted in, that's where we start next time.
One idea and all of motion falls out. That earns going first. What's the second turn on the map?
The second is the one that made me fall for physics in the first place, so forgive me if I get a little warm about it when we actually arrive. It's a trade, a kind of cosmic exchange rate. It says, every way in which the world stays the same pays out a quantity that can never change.
You'll have to unpack that even as a preview, because stays the same is doing a lot of quiet work in that sentence. Same how?
Take the plainest kind of sameness there is. Run an experiment today. Run the identical experiment next week. You expect the same result. The laws don't care what day it is. That's a symmetry. The world is unchanged when you slide it along in time. Or run it here, or run it a mile down the road. Same laws again. Unchanged when you slide it through space. Now here's the trade. For each such sameness, nature hands you back a quantity that is permanently, absolutely conserved.
Give me one, so it's not just floating in the abstract.
The fact that the laws don't care what day it is why energy can never be created or destroyed. That famous conservation of energy you were made to recite in school, it isn't a separate commandment you have to swallow on faith. It's the payout. It's what the world hands you back for the laws not caring about the date.
Wait, conservation of energy isn't its own standalone rule you just have to accept. It's the receipt for a symmetry. For nothing fancier than the laws don't change from one day to the next.
That's the trade. Symmetry in, conservation out. And it's one of the most beautiful things any human being has ever noticed about the world. It was first seen clearly, as it happens, by a young mathematician whose story we'll tell properly when we reach it. I'm not going to say the name tonight, because that discovery has earned its own episode. But there's idea two, symmetry and conservation, two faces of a single coin. And feel what just happened to the pile of things you have to remember. A moment ago, conservation of energy was one law and conservation of momentum was another, and they had nothing to do with each other. Now they're one idea, paying out in two different directions. Two receipts became one insight. That's compression, caught in the act.
Is it just those two, time and space? Or does every kind of sameness pay out something?
Every kind we've ever found. Turn your whole experiment to face a different direction, north instead of east, and the laws don't flinch. That sameness pays out its own conserved thing, the one that keeps a spinning skater's twirl going when she pulls her arms in tight. Slide it in time, you get energy. Slide it in space, momentum. Turn it around, spin. Three obvious schoolroom laws you were made to memorize as separate commandments. And every one of them is really the receipt for a way the world refuses to notice you've moved it.
And notice we still haven't written down one equation. You keep naming demands and showing me what they pay out.
That's the game the whole way up the mountain. Name the demand, watch the payout. And notice we haven't asked you to take one thing on faith yet. Every step we've talked you into, from a demand and its consequence. Hold on to that feeling. It's the difference between knowing physics and merely carrying it around. Idea 3 is the biggest change of scenery in the course, so brace yourself. Everything we've said so far quietly assumed the world is made of little things, particles, tiny lumps here and there with empty space in between. Idea 3 walks in and throws that picture straight out the window.
Throws out particles? That's the picture I've carried since I was a kid. Tiny billiard balls all the way down.
I know, and it's a good picture. It's just not the deepest one. Idea 3 says, what is really there, filling every single point of what you thought was empty space, is a field. Something that has a value at every point, everywhere at once, and can ripple. The emptiness between things isn't blank scaffolding holding up the real actors, it's the main character. Here's a way to feel it. You know how a still pond has a height at every point on its surface, and you can tap one spot and watch the ripple spread outward. Now imagine that, but the pond fills all of space, and it isn't water. It's something you could never scoop up, only a reading, a value, at every point there is. That's a field. Underneath everything, the world is a set of ponds with nobody standing beside them.
A field. So the space itself is the thing, not the stuff moving through it.
Now you're seeing it. And here's the payoff I'll dangle without delivering. Poke a field in one spot, and a wave travels outward through it. And one particular kind of ripple, in one particular field, turns out to be light itself. The person who first wrote that field down properly was a Scot whose equations we'll walk through slowly in their own time. No name tonight. He gets his own stage. But that's the third move, from little particles to the fields that fill all of space. And notice the pattern holding. He didn't memorize light. He wrote down what a field must do, insisted on it, and light came out the far end as a ripple he wasn't even hunting for. The color of the sky, the warmth on your face, the signal reaching your phone. All one field, doing the one thing the demand said it had to.
So when you call a jar with all the air pumped out empty, you'd actually say it's full.
Crowded even. Pump out every last particle and the fields are still there, threaded through every point of it, humming quietly whether or not anything is happening. Empty turns out to be one of the emptier words in physics. That's the whole vertigo of idea 3. The nothing between the somethings is where the deepest action lives. But that is all I'll say tonight, or I'll start delivering it, and I promised you only the map.
From stuff sitting in space to space is the stuff and it ripples. That's a real reversal. And I'm going to guess the fourth idea is the strangest one, because these lists always save the strangest for last.
They do always do that. And yes, it's the strangest by a distance. The fourth idea is the quantum state, and it breaks the last thing you are still quietly holding on to. The idea that a thing simply is somewhere, doing some definite thing, whether or not anyone happens to be looking at it.
That one I'm not ready to give up. Of course a thing is somewhere. It's somewhere even when I close my eyes.
At the everyday scale, sure. But go down to the smallest things, and it quietly stops being true. Down there, a thing isn't a dot with a location. It's a spread-out wave of pure possibility. Here and there and somewhere else, all at once. A smear of could be, until the world interacts with it, and one of those possibilities becomes the case.
A wave of possibility. That's the one that sounds like it can't possibly be true, and apparently just is.
It's the one that costs people the most sleep, and we'll take our time with it. Several episodes because it earns them, and because it's genuinely strange, rather than merely hard. There's an Austrian whose picture of it we'll build carefully when we get there. Again, not tonight. But hold on to the shape. That's idea 4, the quantum state. And I'll say only this to steady you. It isn't chaos. It's not that anything goes down there. The wave of possibility follows a demand every bit as strict as the others, marching along in a way you can write down and trust. The strangeness isn't lawlessness. It's that the law is about possibility itself, which is a sentence that shouldn't mean anything, and somehow runs your phone, your sun, and the ground under your feet.
If the smallest things are waves of possibility, does that mean the first 3 ideas were wrong? Do we throw least action and fields away once quantum shows up?
We don't throw a single one away, and that's a quiet miracle of its own. The frugal path, the symmetries, the fields, they all survive, but they get re-understood, standing on the quantum underneath. The old ideas turn out to be the large, calm face of something stranger going on beneath them. Nothing gets discarded, everything gets deeper, which is exactly why the order matters. You climb up to the strange floor, look back down, and see the earlier floors were holding it up the whole time.
Okay, say the few back to me in order so I can feel them as one thing. I want the whole spine in a single breath.
In one breath, then. First, nature's economy, of all the paths, the thriftiest. Second, symmetry and its payouts. Every sameness buys a thing that can't change. Third, fields, the stuff that fills all of space and ripples. Fourth, the quantum state, where a thing becomes a wave of possibility. A few demands, in that order, and out of them, across this whole season, full motion and light and matter and, near the end, the shape of reality itself.
That's really all of it? A few ideas under the entire wall of formulas that used to terrify me.
A few load-bearing ones, in the order we'll climb them, and the last stretch of the course brings them together, which is a thrill all its own. I'm not claiming these are the final word for all time. I'm claiming they're the spine. Nearly everything in those heavy textbooks hangs off this one skeleton.
And is the order just your teaching preference? Or does it actually have to go economy, then symmetry, then fields, then quantum?
It has to go this way, and that's the loveliest part. Each idea leans its whole weight on the one before it. You can't feel why fields are almost inevitable until symmetry is in your bones. You can't really feel symmetry until least action is under your feet. And the quantum state only lands once you've got fields for it to spread across. The order isn't decoration, the order is the argument.
The order is the argument. So by the time we reach the strange stuff at the end, it won't feel like it fell out of the sky. It'll feel like it had to come.
That's exactly the hope. But before we close, I want to hand you the humbler, truer version of all this, so you don't walk out with the wrong idea lodged in your head.
Go ahead, and I think I know what you're bracing me for. You don't want me leaving convinced this is a finished, sealed box. A few ideas, universe solved, roll the credits.
That is precisely what I don't want. What we've got, these ideas and the mountain of consequence they generate, is the best compression of the world we have ever managed. Staggeringly good. It has predicted things no one had ever seen and been right, again and again and again. But it is not finished. There are places where our deepest ideas grind against each other and simply refuse to fit together.
So even the spine has cracks in it. The pillars aren't the last word, they're the state of the art.
The state of the art, and no more than that. And the very end of this course walks you right up to the edge, to where the compression starts to strain, where two of our deepest ideas won't shake hands, and to the plain list of the things we still cannot answer. Because here's the shape of the trouble, told without spoiling it. Two of the four ideas, each staggeringly good on its own turf, describe the same world in ways that won't quite lie down together. Both work. Both are checked to a degree that ought to embarrass any doubter. And they can't both be the last word. Somewhere under that tension is a deeper compression nobody has found yet. Maybe a fifth idea, maybe a rereading of the four. We take you up to that door. We don't get to walk through it because no one has. I'm not going to sell you a theory of everything because we don't have one. Anyone who tells you this course will explain everything is selling you something.
Doesn't that unfinished business make it feel a bit shakier, though? I half expected physics to be the one place where the answers were finally nailed down.
I'd flip it right around. A finished subject is a museum, lovely and over. An unfinished one is a frontier, and everyone listening right now is early. The cracks aren't a scandal to be hidden, they're the open doors. That a few ideas carry us this far and still leave real questions standing is the most exciting sentence I know how to say about physics. We are nowhere near done. And that is the good news.
I like that far better than a sealed box. A real climb with a summit worth reaching, and the crevices drawn right onto the map instead of quietly painted over.
That's the course. And notice what we managed tonight. A whole hour and not one equation between us. That was on purpose. Tonight was never about the hunt. It was about learning what kind of thing we're hunting. You came in braced for a wall of formulas, and we spent the night showing that the wall is the least important thing in the whole building. Everything from here earns its keep the same way. An idea first, and the formula, if it shows up at all, arriving late and no longer frightening. From here on, we start actually catching them, one principle at a time.
Then let's not linger on the map. Point me at the trailhead. Where do we actually set foot first?
We set foot on the deepest and the strangest of them all, nature's laziness. And I'll leave you with the picture that opens it. Throw a ball across a field. Watch it rise, arc over, and come down. That lazy curve you've seen 10,000 times without a second thought. Now here's the thing to lie awake over. Out of the infinitely many paths that ball could have traced through the air, every wild loop, every zigzag, every possible route from your hand to the grass where it lands, it chose exactly one.
One path out of infinitely many, and it's always the same one?
Always the same one. As if, before it so much as moved, the ball had quietly surveyed every possible journey it could take, and picked the single most economical of them all. No eyes, no mind, no little calculator tucked away inside it. And yet it chooses the frugal path every single time, more reliably than almost anything else in physics. And it isn't only the ball, it's light bending as it slips into water, the planet holding its long loop, a soap film pulling itself into the smallest shape it can manage. Once your eye is trained for it, you start catching thrift everywhere. The world, over and over, spending as little as it can get away with. Next time, we find out what, precisely, it is so careful never to waste.
You're making it sound like the ball knows where it's going before it goes, like it can somehow see the finish line from the start.
That's the exact spell the picture casts, and it's the thing that has haunted people about this idea for centuries. It looks like foresight. It looks like the ball reads the ending and plans backward toward it. It isn't. There's a way to understand it that takes the magic out and leaves something even better standing in its place. But untangling that is the heart of where we're headed, so I'll let it haunt you for one night. A little unease is the right way to end an opener.
That should be flat out impossible, and you're telling me it's one of the most dependable facts we have.
It's the first principle, the one that nearly everything else in the course grows out of. How a ball, with no eyes and nothing at all to think with, manages to choose the thriftiest road. That's where the real work finally begins. Next time.
Then that's where I want to be, with a ball that somehow weighs every road it could travel before it takes a single step. I don't yet see how that isn't just magic, but after tonight I'm starting to trust that it won't be, that there'll be a demand hiding underneath it, and the magic will turn out to be nothing but consequence. Next time then, the principle of least action.